Well, hello everybody and welcome. For those of you who are joining us online, welcome to the Ames Center for our fall colloquium. We're excited to have you joining us. And for those of you who are here with us, we're excited to be together to launch our fall colloquium talk tonight. So again, thank you for joining us. Tonight we get to hear about a special collaboration that has been going on for some time. It's a collaboration between mathematics and art, two topics which you might not think go together on a regular basis. You probably really like one and don't like the other. Maybe you like them both. We're excited here at Ames to think about ways to blur some of the disciplinary boundaries between things that have often been thought of as separate. So in an effort to do that, this talk will focus on ways that mathematics and art go together. And to do that, we have two wonderful speakers joining us tonight, Batty and Aileen Rizo. Leslie is a successful and well-known local artist. She has a Master's of Art from Fresno State University and an art studio located near downtown. Her work explores ideas of feminine identity construction within contemporary Western society through the metaphorical lens of sewing and act of dress. While continuing her art career, Leslie is also a high school visual art teacher who believes in the importance of giving back to the community she loves. Leslie is joined tonight by Aileen Rizo. Aileen has worked in education for more than 20 years. She has served in state capacities with the California Department of Education and various community organizations. And she has two master's degrees, one in educational technology and another in math education, and is currently a PhD candidate studying STEM education at Texas Tech University. Aileen's interests within the STEM fields focus on ways of designing creative learning experiences that integrate culture and art, embrace identity, and promote liberation. So tonight's talk is entitled Teaching Math in an Art Classroom. It's a collaboration of creativity. So thank you to Leslie and Aileen for sharing with us tonight. Thank you to all of you for joining us. The stage is yours. Take it away.
Is this the stage now? Okay. So I'm going to start us off in just, I'm sharing my screen so hopefully you can see that Ames has values that we esteem, but we also try to embody. And one of those is collaboration. And we try to work to create collaborative environments in our workspace. But as we partner with other community organizations, but also teachers and educators, we try to produce or enhance places where there is trust, there's teamwork, and that partnerships are a mutual respect for both parties. So I wanted to just start off with that because that's really important, that there is a mutual respect, that there's co-creation, and that there's just a human-centered way that we are embracing our identity and embracing those things that we create as well and being proud of those things. So let's go ahead and get started. Part of what we looked at was Leslie and I just had a conversation, and if you meet a teacher, you have already a connection with them. And you start talking about the ways that you have similarities and differences. I think that's natural and organic. And at the Ames Center, we really strive to change the narrative of what math and science has been or can be. And we really believe that art and creativity is part of that. So this quote here from this article talks about that we're not just throwing the A and STEM and trying to put some craftiness in there. Right. We're really trying to talk about the ways that it's human-centered, that we integrate art in that because humanity believes in the ways that we are creative and innovative, and we appreciate things that are beautiful. And that's how we're born, and that's how we build community. So I just wanted to start with that quote to just talk about that this was intentional, this was purposeful, and we really try to just have a meeting of the minds and try to think about our students and their well-being and the ways that we can teach to better serve them. So I'm going to let Leslie introduce herself. You've got a little bit of her bio, but to talk a little bit more about her work, and then we'll get into more of what our lessons look like.
So thank you for having me, and I'm really just honored to be part of this and to be able to share. And I really get so much out of our collaborations when Aileen and I put our heads together and we come up with we really do nerd out on how art and math do really overlap, because there is some, sort of narrow ways of thinking about each academic area that I think that we have kind of broken through. So yes, I did do my master's degree in my grad school in arts and emphasis on painting and drawing. And I think a couple of things that are unique about my experience in arts is that I didn't start out intending to be a high school teacher. And I really wanted to be a studio artist and make artwork and just, really do that side of art and not so much in education. I wasn't thinking that at first anyway, but it's become really an extension of my studio practice is the teaching aspect. I think that another thing that sets me apart with that is that I really did establish a studio practice in Fresno, and I am part of a collaborative gallery that shows local art that is not commercial. We're a cooperative gallery that wants to provide opportunities for, art to be conceptual and to be contemporary and relevant for academic studies. So I started out after grad school, I started out teaching at the museum, at the Fresno Art Museum, and doing some docent work. And then I went into college, an adjunct in the colleges, the local college system. And I taught at several different campuses, and it was all part-time, but I learned so much from doing that. And so then I decided, I need to see what I can do full time. And they were hiring at Sunnyside High School, and I have a friend who works there. So I applied and I got the job. And even though the age difference are not so much different from high school to college, it's a huge difference just in terms of providing materials and just the amount of students. So I've been there for this is my 5th year. Anyway, I feel like I learned so much from them too. And I just feel like I have this unique opportunity to connect with other teachers, to connect with students from all these different backgrounds. And it really does inform my studio practice too, when I have time to do it. So anyway, I do still show work, and I'm still, a part of Corridor Gallery, which is in downtown Fresno. And I just have had to reorganize how I participate. And again, I just get so much out of extending into teaching what I do in my studio. So one of the other things that Aileen asked me to speak on was this idea of collaborating with art and math. And it's very conventional thinking that, art and math don't really go together. One's really creative and one is, very precise, and, there's one right answer. And it seems like they wouldn't go together. And that's sort of the general thinking about that. But Aileen and I have discovered that is not true. And I think many people have, but we would like to bring some of the highlights out that we discovered in ways that art and math really do intersect and overlap. Some of the conventional ways of thinking is that math and art, is that art is easy and math is difficult. That art has no structure and math has no creativity. The struggle against perfection. In visual arts, we hear, I can't draw, or I can't draw a straight line, or all I draw is stick figures, things like that. And in math, we hear, I'm not a math person. And so I think that challenging those notions is really important, and it's difficult to do because it's really ingrained in our students, and I think in the general population.
So we're just going to share a few pictures. These pictures were from before the pandemic. So Leslie and I had met, I don't even know like how many months before, but we had met and then we were just talking about the vocabulary. I think that's the first way we started connecting, because you were teaching a 3D design class, and there was this idea you were talking about implied 3D and then actual 3D.
Right, like form.
Like form,
3D.
Yes. And so we were talking about those things. And so we decided to kind of collaborate around a lesson together. And so I got to visit her classroom and got to just start seeing what it was like. I'd never been in a high school classroom before. So I got to see what that was like and what they were learning, and how there was just a lot of overlap. And we just started getting curious, like, what would it look like if instead of me as a math teacher trying to bring art so I can engage my students, what if you brought math into the art class? How would students react? How would they learn differently? And so we had this collaboration together, and we made some origami models. And what we both, I think, were struck with, but especially me, because I had done origami in classes, professional development with teachers, doing model lessons. And I had seen students like make these, and then we would talk about the attributes of these shapes and what they were called and the things that we noticed about them. And so I have edges, and I have surface area, and I have volume, and I have faces and vertices. And in all of that, I had hoped that because they made something, it would really create an experience for them to remember the vocabulary. But when we did the same thing in the art classroom, students started creating things with the models. So we didn't tell them make a sculpture or they started making this, and they said it looked like a bridge. And they just started doing these kinds of things. And it really struck me, because I was like, how come students are aware that creativity is kind of expected of them in this space? That they would do something outside of what I had asked them to do, and not just said, okay, I'm creating my cube and I'm done. It was like, what else can we make? What can we make out of what we made? And they started collaborating and putting their shapes together. And that was really, it spoke a lot to me, because I want that creativity in a math classroom. I want that invitation extended to them when they're a problem solver. I want them to think outside the box and share their strategies. So how could I bring some of this culture into a math classroom? Maybe one way is this collaboration will teach us a lot about how those characteristics can be shared between those classes. So after we taught the lesson together, we started thinking about another lesson that we would do together. And it just came, like, I think out of a conversation too, was one of the other times I walked into Leslie's classroom, these pieces of art were on the wall, and Leslie started explaining how symmetry, or the lines of symmetry, are used to create this art. And I'm going to hand it over to her so she could explain some of the attributes of this type of art. And then we're going to give you a chance to try and explore a little bit.
Okay, so this type of design project it's called Notan design, and it's a Japanese principle, I guess you could say, where you start with a black square. And I'll just tell you as a kind of foundational idea, yin yang is a way to think about it. Okay, so it's like positive space, negative space. And you start with a black square against a white background that's quite a bit larger so that you have space around the black square. So I think I do the 9x12 Bristol paper with a 4.5-inch black square. And then I do have my high school students do kind of a little exercise with some, like a rough draft, but the principle here is making shapes into each side of the square. And then when you cut them, you flip them out. And each side of the square is a line of symmetry. So one way that so you can maybe see these principles that I'm talking about as I'm saying them. If it's cut directly from the edge, it flips out so that the edge of that line stays in line with the square. So it just flips out. But if it's cut from inside of the middle of the square, when it flips out, it needs to stay symmetrical in terms of its space from that side of the square. So just think of that as the line of symmetry, regardless of how deep into the square you cut the shape. The creative part of it, besides just making up the shapes and how many shapes you make and are there internal shapes, etc., is that each artist gets to choose which side of the square will be the line of symmetry. So in this example that's here, pictured here, you can imagine that the stars, instead of flipping up above the top line of symmetry, the artist could have chosen to flip them out on the left side of Saturn, or to the right on the other side of the face, or below the sun or star. So if a shape flips out, then an internal shape will flip back in, and so on. So
there's another example.
Right, okay, so yes. So this one doesn't have any internal shapes. This one is all shapes that are, okay, let me rephrase that. There's a shape in the center. I guess you could consider that internal, but I'm saying there are no shapes within shapes. So there's no shapes cut within shapes. So for example, this student could have made a little circle, like a little owl hole in the tree, and flipped that shape back in if they had wanted to, or like a smaller cloud inside of the larger cloud. And you can keep doing that, concentric shapes. Yeah, so this one is a little more abstract, although you see the hand, a representational hand, but you can see here that some of the triangle shapes have an internal triangle that's flipped back in. So there are a couple things about this one. I love this one. I think it's amazing, but there are a couple of things that don't follow the line, are the principles of NOTAN. And that is, should I ask if they can see what it is?
Oh yeah.
Okay.
People can respond.
Yeah, so I would love to see if any of you can. I do this sometimes with my students.
The two corners.
Oh yeah, she already got it. She got it. So if we're using lines of symmetry, then the two on the corner, even though they are flipping it out, they're flipping it out on diagonal instead of on a, how we think of a bilateral symmetry. And so those wouldn't really follow the NOTAN principle. With high school students, however, I'm not but I do want them to learn to follow the, the instructions in a way so they really can demonstrate that they understand symmetry and the principles of NOTAN. Another thing is that no pieces should be missing. Every piece needs to be accounted for, and the NOTAN principle has this kind of underlying belief that if you do this correctly, regardless of what side you decide to flip the shapes outward, that it will have balance. It will have an inherent balance. So I think it's really beautiful, and it reminds even the most simple shapes. Even if you just cut one shape, it's like the positive and negative shapes still balance. And it's I don't know, it has a kind of meditative quality. Can anyone identify what the
I'll keep quiet
student
this time.
The top,
didn't do?
the
Yes.
top piece.
So the top piece, they didn't only flip it out, but they like inverted it. You almost don't see it at first because it still looks kind of cool. But they did a great job of, lining the edge up, really keeping it in line so that you always should see that shape of the square should always still be present. Okay, so during critiques, because I have 6 classes, I just kind of put some labels up like a grid on the board with numbers and letters so we can easily identify which one students want to discuss. And so this is from one of my classes, and not all of them are done. Not all of them are done completely, with accuracy, following the principles, but you can see it's a very dynamic, it creates a really dynamic design because of that positive, negative, that high contrast. And then during critique, we will discuss organic shape, geometric shape, representational, abstract and non-objective ways of representing, images. We talk about pattern and visual rhythm. And I do believe that, a lot of times art is not considered an academic field of study per se. I think sometimes people think that visual arts is just, a place for kids to play and, be creative and, a little less structured. But there are so many terms that are in line with the math vocabulary and that are really applied and used in our class and in the art classes. And I just hope that this will help you to see that part of art and design today.
So we're gonna give them a chance to try to create a notan.
Okay.
So everyone that's here has some materials to use, and let's say if you want to come up here, I can get this camera onto you, and then you can take those who are with us virtually. I think there's 9 people here, and we will and share this camera with them.
Okay, and so should I explain, like if they're at home and they don't have, should I explain maybe what materials they can grab?
Yes,
Okay.
we I think we said something, but just to summarize
Okay.
it, yeah.
Okay. So something that there's so many different materials you could use for this, but as long as you have a white background that's a larger size, and then a dark paper, even if it's not blue, even if it's, black, you could use like blue or some other color, as long as there's some contrast. But it has the most pop if you use black. And then you'll want enough space around the sides to be able to, when you flip out, I do tell my students, wait, where should I be looking?
You can look straight here.
Yeah, that's fine.
Okay. When I look up here, I see my back of my head.
Yeah, you can look forward.
Oh, okay, we're here.
Yeah.
Okay. So one thing that I will want to, I guess, point out is that if you're square, I would say maybe like 4 inches. I don't know if you have a ruler, but like a 4x4 would be perfect here. But I would also suggest when you're thinking about flipping it out, I tell my students sometimes think about if the square were like, each side of the square was like the center of a book where you would be flipping the pages. So imagine if you had a page that was flipping out from each side of the square. It's a way to think about or conceptualize how that would work. In order to if you have a ruler, you can just, oh, okay. If you have a ruler, you can, and you have 9, is this probably by like a 8 by 10 paper? Okay. And so you can measure it out, or you can, honestly, it's still gonna look really great if you just try to get a square. And you guys are math people, so I guess I don't have to emphasize that aspect. But I think I feel like 4 inches would be good. So I'm gonna go ahead and measure out 4 inches. And then once you have that, you can go ahead and draw the line, and you can measure down here to make, if you want it to be very precise. Make sure you have 4 inches from the edge. I do teach my students about measuring. We always start at 0. I grew up with a family that used tape measures and like seamstress measuring tapes. So I grew up with this idea of precision with measurement, but not like many students have not. So I teach that in my class. Okay, so go ahead and cut out your square. And at school, in my high school classroom, I have it already cut for them. Okay, so once you have your square, one thing I would like to point out is that you don't want to glue down your shapes until you have an idea or a sense of what you want your composition to be. Because sometimes when we're flipping things out, we don't really always imagine how much space it will take. And then you want your composition to be balanced. So I don't suggest gluing things down. I know sometimes students will want to do that so that they don't lose any pieces. But it's a good idea not to do that right away. Okay, so at this point, I do have my students look up Note 10 designs and just kind of explore different ways of designing. Should we, I think it's a good idea just to kind of think about, do I want to do organic shapes or geometric? Do I want to make a scene that looks representational? So it's really up to you if you want to kind of Google images. I do allow my students to do that because it helps them to feel inspired and have a goal. So they're not just randomly like, okay, I'll just draw something, but it helps them to think and plan a little bit more. And I do have them do a rough draft with like printer paper and some just construction paper. But okay, so in this case, I'm going to just do some organic shapes. And I usually start at the edge and just start drawing just something kind of random. But I guess I've done this enough times that I do have kind of an idea in my mind what it might look like. And you can put shapes within shapes or do like, 2 shapes within one.
When you're doing that, do you visualize the end product already?
I think that I do, but I don't think it's necessary. I don't think you have to, but I do just because I've done it several times, I think. So that's something sometimes it's hard to be objective about, like what I'm envisioning, but I do think that I have an idea of what it's going to look like. Okay, so I do think it works. It's more straightforward if you don't draw onto the corners, because that makes it a little bit more challenging, but you still can, as long as you just think about the line of symmetry being on the sides. I do have students that will turn it this way, and I think that's still valid. Like it's just the formatting looks a little different, but it still looks pretty cool. But you can do on the corner, just, can make it a little more challenging. Okay, so then let's see. And then if you're going to do an internal shape that is like inside the square that's not cut from the edge, you will need an X-Acto knife. So I don't know if we have X-Acto knives and cutting mats, but if you have that at home, go right ahead. Otherwise, I guess you can sort of cut in from the side, but it's just a little less nice or clean looking, I suppose.
So in like a classroom in here is quiet.
I know. My classroom is never this quiet. And I hope you'll forgive all the paint on my hands. I came straight from school today and we're painting some large paper mache things. So, okay, so I'm going to go on some of these, I'll go a little bit. I guess I'll do an extra shape inside. So it does create more dynamic kind of situation. Okay, so after you draw some shapes, should I wait for a little bit or? So maybe I'll just ask those of you who are here in the this physical space. Do you feel like you need more time for drawing shapes, or did you have enough time to? You're already done? Oh, you're already cutting them out. Okay. All right. Okay, so then I did all mine from the edge. It's just more straightforward. I'm gonna cut those out. It will work.
I don't know.
It will. It can be challenging sometimes, especially I've had sometimes students will cut things out and then overlap the shape where the shape will go on the other side of the line. And that really creates an interesting positive, negative, like conceptual dilemma, I guess. Because it's like, okay, if this goes in and this goes out, it's like in a Rubik's Cube or something. It's this positive and negative space. It's like, where does this piece go? If the shapes are overlapping. It's hard to explain without actually getting into that situation. But I could demonstrate, but it could take a long time. Okay, so I just, after I cut them, I sort of put them back together, almost like a puzzle piece. And then it can, sometimes when I do, when I decide to glue them down, sometimes I'll actually choose to flip the whole thing upside down if I feel like I made too many pencil marks. But just keep in mind that some of the shapes are flipping out and will be upside down anyway. Okay, so I guess while I'm cutting, does anyone have any questions about this process or the principles underlying it? Okay. And I will say too, like some of my students are, I'm the only class that they take that is in like a mainstream classroom. And this lesson can be very easily modified into, being more complex or being more, fewer steps. And it looks beautiful either way. In fact, sometimes the more simple, the more don't know, just like impactful it can be. It's hard to go wrong with this one.
Well.
I think it's great. I think it's going to be great. Don't worry.
Well, Leslie, one of the things that we often talk about in like when it comes to learner, like designing for learning and designing for creative learning is we want there to be a very low floor and a very high ceiling. So that idea that whatever skill or expertise or even sort of attitude towards something that you come in with, that you can easily get started with something, and at the same time, it can be expanded or the activity can continue into some higher levels of creativity or
Right.
something.
Yes, I would say that with this lesson in particular, I've noticed this with certain lessons in high school that I hadn't noticed because I started teaching this at City College because one of the chair of the department showed me this lesson and I was like, oh, this is really neat. So I started teaching it there and I just brought it to my classroom. Oh, so sorry. I thought I turned that off. Sorry about that. The thing that was really amazing was that students were really challenging themselves without much prompting. And I think that having them, because a lot of times students will like just, okay, what do I have to do to get an A? Like, what's the easiest like path to, I'm so sorry. What's the easiest path to solving that?
Mm-hmm.
And they will start looking at the images online, and that's where they start getting ideas. So I make sure to have them do some exploring and research some different designs. And I said, I just tell them, like, pick something that you like and try to, do something that inspires you. And I don't even tell them, try to pick something really hard or really, that seems a little harder than you can do. Not with this one. It's like, I just say, look up some designs and see which ones you like. Try not to copy it exactly. Try to, even if you get inspired by one and you take a few design tips from it, try to somehow make it your own. Because that's what we do as artists, is we keep expanding and growing and coming up with new concepts. And so it's always so interesting to me that they always do challenge themselves more than I think they would. So I came directly from work today, and I'm so sorry about this. I'm gonna make sure that's turned off. Okay.
Well, Austin is online. Austin said, Austin's a primary math interventionist and says this would be a great lesson to tie geometry and area. So really kind of thinking about some of those core mathematics concepts. Thanks for sharing that, Austin, and feel free to unmute and tell us more about that if you're interested. If not, that's okay too. But yeah, a lot of neat connections into particular areas in math that this would be connected to.
I'm going to take it way past his do it, Mary.
Keep going.
So talking about area and cutting, I had tried to get a concept through to my AP calculus students, and they just couldn't seem to figure out why we did anything regarding area under a curve. So I handed them a piece of blank copy paper, a pair of scissors, and I said, have fun. They made snowflakes, but I said I wasn't giving them a trash can. They had to keep all the trash on their desk. Any guesses where this went? Their next problem was, now that you finished your snowflake, can you find the area of the snowflake? They just about all strangled me. But my point of understanding that we subtract one from the other to get the total finally got through when they realized I had the area of the paper to start with, and we had all the pieces that they could calculate areas of from their simple cuts. And it finally realized why we could take and subtract one curve from the other for calculus. So, not only is this simple geometry for lower grades, it's goes all the way up through to get them to understand area and how things cut and paste and still put things together.
Yeah.
That's really cool. Yes. I want to learn more and more about this and how it relates to math. I never even thought about how it might apply to something like area. I had only really thought about symmetry and then using like vocabulary that, like one thing I learned that I never knew before I started collaborating with Aileen was that side is a 2D word and edge is a 3D word. I didn't know that. And I'm teaching 3D design. Didn't realize that. So we kind of merged our vocabulary and there's so many similarities. But I think how great for students because they're leaving my class or coming into my class after being in geometry. And now it can make more sense to them. Like if we're integrating our lessons, it just helps students to be able to integrate what they're learning and then apply it beyond, which I think is super exciting. Okay, so once you put it all together as a puzzle, then you want to think about where is my, the base part of my square. And then from there, you're going to take the largest shape. So the second shape in, so you might have 3 shapes, like this one is 3 shapes, but you want to start with the largest shape. If you have like concentric shapes like this, is that the right term? Concentric? Okay. And you want to just take that largest shape and flip it out. And you want to think about the line of that represents the side of the square as
Playing
lining.
topology.
What's that?
You're playing topology.
Yeah, that's true. Yes, see, I'm learning. I never even thought of that. And actually, my shapes really do look like a topographical aerial view.
When you put it back together.
Yeah, when I was cutting these out, I was thinking lava lamp.
Okay.
And like shapes in front of, or, blobby forms in front of other forms. But now I'm thinking of it as an aerial view of a topographical map. Okay, so you take the largest shape and flip out, and then you leave the second shape. And then if you have a third shape, then you would flip that one out. And then I think too, the trick is not only not losing the shapes if you have lots of them, but also keeping them, the orientation being accurate and not dropping them. So, okay. And then so this is the part where it's like, okay, if I glue this down, I can line it all up. But then you have to think about the overall layout too, and how it relates to the edges of your picture plane. So that is also one of the design challenges that we want to consider when we do No-Tan. I'm taking the larger shape and flipping it out. And then once you have all these flipped out and you kind of have decided, so I haven't shown you yet the variation. Oops, that one stays in. I haven't shown you yet the variation on what line of symmetry you want to choose, because we don't have to flip it out on this same line of symmetry. We could do it a different way. And so that's another way of being creative besides just picking your shapes. So that's generally mine. So you can kind of see what it's going to look like, although they're kind of, curling up a little bit. You can generally see. And so now is my chance to move it around. You know what? I'm feeling some SpongeBob vibes from this one.
Yeah.
So now I could actually decide, okay, it looks like there's a little bit more distance this way. So that's a little more than 7 inches. And this way it's only going out like 6.5 inches. So since this way is longer, I might choose to take the whole design and spin it. So that's one possibility. And then another way that you can think about this design is instead of flipping it out, we could flip it on this line of symmetry. So if I put these pieces back the way they were before I flipped them, and then I take the largest shape, and instead of flipping it on this line of symmetry, I flip it on this one, it would go out this way. And now I want to this does challenge your, visual astuteness, I guess, of ways of looking at proportion. And while I don't have kids measure it or anything, I tell them really look at the relationship between the shapes. Look at the negative space, look at the positive space. Are you really creating a symmetrical situation, or are you not? Okay. And so then they actually have the choice to either flip this one out here, or they could just keep it here. I keep dropping it. My fingers are kind of, I think, messed up from all the paper mache we've been doing. Anyway, so they could still flip it out here, or they could flip it out here, which it would look a little alone, and but still you can see that it would be much further because right. And also if I'm looking at the distance between this and this, I can now imagine that this and this would be the same distance. And even without a ruler, you can kind of look at the distances. But I do think that this would probably not be the first choice that someone might have. You can also decide to flip it on this line of symmetry, but you would need a much larger piece of paper. You would have to go way over here. I think I have that backwards.
Even if you cut the same figures or forms, another artist could choose different placement,
right?
Position.
Yes. And it still is following no-tan. And so every piece has to be accounted for, which would really help with your floor situation. Because if you're if there's anything on the floor, I don't want you to sweep it up today. Today, I want you to pick it up and make sure it's in your design. So it does really eliminate that issue. Okay, so there's so many ways of flipping these out, but I guess I am just going to go with the standard way here. So any questions? And when I say standard way, I just mean the obvious, the obvious closest line of symmetry. And then you'll need a glue stick, and as soon as you feel like you have your spacing down, I do, and this is how I was taught too in design school, is that art and design school, is that when you're putting work onto a picture plane, that it should be slightly higher. It should be centered this way, vertically centered, but horizontally should be a little bit higher so that you have a little more space at the bottom. And I don't believe that there's a mathematical formula for that or standard, but it is something that is I think maybe relates to the rule of 2/3, which they teach in or the rule of thirds that they teach in photography.
And the golden ratio.
The golden ratio, yeah. So I think it has something to do with that. I will be transparent that I don't know exactly how those tie together, but I think it has something to do. Anyway, just having a little bit of space at the bottom, it just is gives a more balanced feel to the design. Okay, so then you can go ahead and glue those down and trying to keep, I would start with your center square if you can, imagine the spacing that you want on the sides. So a lot of times your square is going to be off center. So I wouldn't be dedicated to making that square centered. Really look at the overall composition because, it's very possible that with just a 4-inch square, you could have a 12-inch span of shapes in your design. So I don't know if you would want me to glue this down right now. It would take me a little bit.
No.
Okay, so I hope
Time is
everybody
coming down
gets
to
it.
end.
Yes.
But we just wanted to show you a little bit more of what that lesson looked like. Sharing some screenshots of the classroom. The students had done some investigation using mirrors, and it acts something like a CD case. The CD case is something that also could reflect very easy. But we were having students investigate like alphabet fonts and look at the ways that they were seeing the line of symmetry in those letters and talking about where the line of symmetry was, whether it was horizontal or vertical. And this was really to emphasize that ability to recognize it and for students to see it in their environment. I think we see that, but really to notice and be just a little bit more technical about it, detailed about it. So we did some like preliminary activities with the Mira, and then they did some folding so that we could relate not only line symmetry, but rotational symmetry with the students. I think they call it radial symmetry in art. So they were making, if you see on the one side of the screen, kind of like a ninja star, I think it's called, that model, but it's very 2D. So they were making 8 different origami folds and then putting them together to make this, it's a model that looks like a wheel, but then you can turn it into more of a gear. And we were talking about how much does it have to rotate to look exactly like the same form where it started. And then we did some 3D models, and the students did something again that I had never seen anyone do. They put 2 of those models together, and this is what it looked like when they put those together. So what they did was they made one, and then they put it inside of the other. And I had never seen anyone do that, but the proportion with the paper and how this model rotates made it very easy to do that. And that was another way that I was seeing them sort of creating things out of the models that they were creating. I think I just have like a real quick video here that shows exactly what that looks like. And so the pieces are 2 pieces and they look just like that. And in the Ames original origami book, it's called a Flexa Star, and you make it with 8 modules, and it rotates in the center. So it has like this 3D rotation that it can go through. So what the students were doing is they were opening up one, and then they were placing that one inside of the other, just like you're seeing there. And I had never seen anyone do that. And that was another way they were just really exploring with the creativity of the modules that we were creating and putting them together with each other and creating new things. So I really feel inspired as a math teacher to think about these ways that students can be creative and really opening up an invitation for them to be creative and to create new things that maybe not everyone thinks about. And this was one of the things that I saw them do.
Can I add one more thing too? Something else that I feel like is maybe obvious already, but that Aileen and I both talked about how we both feel like learners when we're teaching together. Like we're both, wow, oh my goodness, like look what they're doing. I feel like we're really experiencing being in the learning seat and really learning more. And I think that's so inspiring. It's inspiring as a teacher to feel like you're expanding your own way of understanding a lesson that you've taught for years. You know, it's like really, I think that's something important to bring up.
Absolutely, because I think that that's one of the important things that we learned together was that we're all novices in different areas. And what we maybe thought of as a, you know, usually when collaboration happens, the math and science teacher work together. And we try to make ways that, you know, oh, you're using a lot of math in your science classroom, say it's physics or chemistry, and they work together, and those are great collaborations. What I found out is that it wasn't so far-fetched to try to teach math in the art classroom. And that at the end of one of the lessons one day, they were, you know, creating these modules, and then we were taking pictures. And then I remember Leslie saying, so did you have fun doing math today? And they're like, we didn't do math. And she's like, yes, you did. This was like all math. And they're like, don't ruin this. Don't ruin this. And it was funny, but a little sad for me as a math teacher, because I want them to feel that way about what they're doing, that they're excited that they're doing math and they're seeing the creativity. So
they did say, Ms. Rizo, can you come teach math at our school?
Yeah,
we like the way you teach math.
Yeah, they did. So that was very, very nice of them. We're going to close because we're a little over time, but I just want to thank Leslie for opening up her classroom to these lessons, for the invitation to always work together, and for just the ways that I've learned from you, and we've been able to hopefully expand the students' learning and knowledge in ways that maybe others can take our example and do likewise in some ways. So,
well, and I want to thank to Aileen for suggesting that we do this, because it's been such a cool, amazing part of helping me to sort of be innovative with my own teaching. So thank you very much, and for having me.
Thank you both. Thank you, Leslie and Aileen. Thank you to all of our participants online. Thank you to our participants here in the room. We hope that this talk has been both inspirational to you and also provided some practical ideas for ways that you might try some of these things on your own, try some of these things with other learners, and maybe even foster some interdisciplinary connections in whatever environment you find yourself in. And we also invite you to join us for some upcoming play shops. Here at Ames, we believe that a workshop is outdated, and we prefer a play shop. So join us on some Saturdays to explore the same kind of thing we just explored today. Creative ways to think about designing learning experiences that cross disciplinary boundaries into art, into humor, into play. We're going to be doing some things with light up circuit pop-up cards in December, weaving in January, and working with automata toys in March. So join us today. It's a free event. We'd love to have you participate with us, and you can find more information on our website. Again, thank you, Aileen. Thank you, Leslie. And thank you all for joining us. Have a great night.